Okay, actually, gotta make sure I share my screen. Oh, let's try this again. I don't know why it likes to flash. There we go. Okay, so I'm going over section 5.1, which is about the rectangular system and about graphing. I know people usually have a little trouble with graphing in ALEKS, so I am going to make sure I do probably the most difficult one. I'm going to go through that, show you how to graph that in ALEKS. I also have a tutorial that I've added to the cheat sheet that can help as well. So we've got some vocabulary to go through. We have basically the rectangular coordinate system. So when you graph and you have 2 dimensions, that's called the rectangular, or it's also called the Cartesian coordinate system, and it's named after René Descartes. That's where we get Cartesian from. And so we have a grid, basically, and we have 2 axes. So these horizontal and vertical lines are called the axes. So the horizontal is called the x-axis. So IS is a singular, ES is plural. And so we label that with X. And then the vertical is called the Y-axis. Usually the X is input, the Y is output, or the independent variable, dependent variable. So this is also used in science. You may, instead of like X and Y, they might say independent and dependent variables. So X is the input or the independent variable. And then Y is the output, or it's called the dependent variable. And it's called the dependent variable because it depends on what you have for X. So you generally plug in a number for X, and then you get an output. And it depends on what you plug in. So that's why Y is called the dependent variable. So the center is what we call the origin. So that's just the most center dot. And we refer to it as 0, 0. So we have what are called ordered pairs, which is basically just how we call the point. And it's a pair because you got a pair of numbers. You have an X value and a Y value. They're called ordered because they're in a specific order. We do alphabetical order, so X comes first and then the Y. And so the center of our graph is always referred to as the origin, or 0, 0. So everything counts from there. So on the x-axis, it's just like on the number line. The negatives are to the left, the positive are to the right. And then the y-axis, you can think about it as like a mountain or elevation, where positive is up, negative is down. So like below sea level, you're going down below, and mountains have a positive elevation. So that's how we refer to our, basically the numbers, and which direction is positive, which direction is negative. So you can see that this is divided into 4 sections, which we call quadrants. Quad comes from 4. And we count counterclockwise when we name the quadrants. And a lot of things when you go on a pre-calc and you talk about trigonometry, that is also counterclockwise. So we start with quadrant 1, where both the x and the y is positive. And so that's why it's labeled with plus, comma, plus, because both of those numbers are positive. And then we move counterclockwise to quadrant 2, where the x value is negative because it's to the left part of the graph, but the y value is positive because we're still in the upper half. Then quadrant 3 is below it, where both the x and the y are negative. And then we have quadrant 4, where we have a positive x and a negative y. And this is just the convention that we have used. And for graphing, you know, we've got these definitions, and this is just convention that we name everything and we go counterclockwise. So as I mentioned, points, when you plot them, plotting is called basically putting the dot on the graph. We say that's plotting. They're called ordered pairs, and they're in the form x, comma, y. Your x value first, and then your y value is second, because it's alphabetical order. And so we always first go horizontal and then vertically when we're moving this. And so this picture, you can see how we've got multiple ordered pairs. And you can see why it's called the rectangular coordinate system, because if you take a point and kind of draw lines to where it matches on the axis, it forms a rectangle. So that's where we get the name rectangular coordinate system, because we're basically forming rectangles with our axes when we plot a point. And so you can see on here we've got in purple 0, 0, so that's the center. And then the light green, we have 2, 3. So it's at 2 on the x and then 3 on the y. So you're just kind of reading off of the graph and looking for the intersection if you were to extend and make a rectangle. In red, we have -3, 1. So you can see that the -3 is the x value, 1 is the y value. And then when you have decimals, you have to approximate. So in blue, we have -1.5 and then -2.5. So we're about halfway between -1 and 2 and -2 and 3. So you have to kind of approximate where those values are. So first thing we're going to do is plot ordered pairs, identify which quadrant or axis it lies on. So I'm actually going to go straight to Alex, the week 4, number 4 graphs and equation. We're going to do problem 1 together because that's the one where people struggle with the graphing. So we're going to just do that one together, and then I'll verbally talk about which quadrant or axis it lies on. So let me get that open up here. Okay, so I'm going to just skip these parts until I get to the actual graphing part because I want you guys to actually try to answer these on your own. I really care about the graphing part that I want to demonstrate. It's part 4 that has the graphing. Okay. Let's see if I can zoom in a bit. Okay. So we're plotting, we've got 6 points here. They've labeled them A, B, C, D, and F. And we have this graph. You can see when I hover over the graph, the cursor changed to a plus. This button here is for erasing a point. This is for plotting a point. You can see that it helps you plotting by forming those rectangles. So when you click that button, it will form the rectangle so you can make sure you have it lined up correctly. So we're going to go in order, and we're going to first do -2, -3. So the first value is x, so I want to go to -2 on the x, and so you can see it down here. I want to make sure I'm lined up there, and then -3 on the y. So I want to make sure that I'm lined up to -3, so it's down here. And then I need to make sure that I'm lined up. I'm still at -2 on the x, -3 on the y. And then I'm going to just click. And now I have my point there. You can see the little blue X. It's really, really tiny. Now we've got these decimals, or well, we've got fractions and decimals, and we've got some other interesting things to graph. So I'm going to turn that off for now. So that's where you have to take a look at your graph and see what is it counting by. So I'm going to zoom in some more so we can really zoom in. Okay, so let's say from the center, I need to count how many dashes I have here so I know what I'm counting by. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and then to get to 1, it's 10. So that means there's 10 divisions, so I'm counting by tenths. So every little tiny line here, we call them tick marks. Every tick mark is worth 0.1. So when I'm given a fraction like this, I'm going to have to convert the fraction to a decimal and then round it. So for B, I need to do 7 divided by 3 to get it as a decimal. That's 2.33. Now, since I'm only counting by 0.1, I need to round to 1 decimal place. So 2.33 repeating is 2.3. So I want to make sure that I'm at about 2.3. So I go to the 2. And then I need to move over 3 more tick marks to get the 0.3. Now the y value for point B is 5 over 2. So what I do, 5 divided by 2, that's 2.5. So my y needs to be up at 2.5. So I need to be very careful here with my mouse. I don't want to move the x. And I'm going to go up 2 and then up 5 more. 1, 2, 3, 4. Oh, shoot. 5. You want to be very careful. And if you move, double check that I'm still at 2.3 and I'm at 2.5. So now I'm going to click. Okay, so now let's look at C. So I'm at -2 on the x, so that's easy. I'm right down here. And then 3.4. So I need to go up because that's positive. I'm going to go up to 3. And then the 0.4 means I need to go up 4 ticks. So 1, 2, 3, 4. I need to double check if my x is still on -2. And then I click. D here we have 3 and then -pi. So my x is at 3. Actually, I'm going to need to scroll down here for -pi. So pi is a number that goes on forever. It's 3.141592, and then I don't know what the rest is. But we only want one decimal place that we're rounding it to, because that's what our graph allows us. So if you round pi to one decimal point, that's 3.1. So for point D, my y value is going to be -3.1. So I'm making sure I'm at 3, and then I want to go down to -3.1. And I'm going to click. Now E is 0, and then I go up to 3.4. The 0 means you're not moving left or right on the x. So I'm going to stay here, and then I'm going up to 3, and then 0.4. 1, 2, 3, 4. And then F. So F we have for the x value, the square root of 7. So you need to put that on your calculator. And that gives me 2.645751311, and it just keeps going. So I need to round to one decimal place, and that comes to 2.6. So I'm going to make sure that my x is at 2.6. So I need to move 6 over from 2. 1, 2, 3, 4, 5, 6. And then the y value is 0, so I'm not moving up or down. So that's where my point is. So now I've plotted all of these points. This right here, I'm circling, that is in quadrant 1. This point we don't say is in a quadrant because it's on one of the axes. So we say it lies on the y-axis because it's on top of the y. This point is quadrant 2. Then if I can get this to scroll down, there we go. Down here, we are in quadrant 3. This here is quadrant 4, and then we have this is on the x-axis because it's on the horizontal line. So we've got quadrant 1, y-axis, quadrant 2, quadrant 3, quadrant 4, x-axis. And now I'm going to check my answer. And there we go. So, and note they do have this note here, approximate irrational numbers to one decimal place for ease in graphing. To warn you that you're going to have to round to one decimal place so that you can graph these. So that's how you plot points. And that's how you do it in Alex. So now I'm going to go back. So actually, before I move on to the distance formula, are there any questions so far? Okay. Next, we've got the distance formula. So this is a formula that you use to basically find the distance between two ordered pairs. On a graph like what we just saw, the distance, the units are they're just called units. They're not really any units to something like that. But you can use the distance formula if you actually have like a physical, like if you had a map in front of you, you could have units on your distance. It could be miles, inches, whatever you're plotting by. So the distance formula can give you something with distance if it's like a real application. But if it's not in a real world problem, not a word problem or anything like that, you're just plotting points, there's not really a unit. It's just a distance, a unitless kind of thing. Or sometimes you might just say it's 5 units away. But it gives you the distance between 2 ordered pairs. And when we're looking at a map, we have 2 ordered pairs. We've got a latitude and a longitude. So we've got an X and a Y value. And you can use that on a map to actually find distance between places. So the distance formula comes from the Pythagorean theorem. The book goes through how you can come up with that equation. But I've got the formula here. D equals, and then you've got this whole long square root thing going on here. But it's x2 minus x1 quantity squared plus y2 minus y1 quantity squared inside that square root. One way we can use the distance formula is to determine if 3 points form a right triangle. So if you've got 3 points, A, B, and C, you need to find the distance between each of those. And I don't know why I have a question mark here. I must have accidentally hit that when I was typing. The distance between A and B, the distance between A and C, and then the distance between B and C. So you get 3 sides, basically. And then you figure out which ones have the smallest distance. The 2 smaller ones you label as A and B, and then the largest is C. And then you plug them into the Pythagorean theorem and see if the equation is true. If it's true, you have a right triangle. If it's not true, it's not a right triangle. So you can use the distance formula to determine if something is a right triangle. That is helpful in a map, perhaps, if you're just, needing to find if you have a right angle or whatever on a map. So let's go through and use the distance formula here. We want to find the exact distance between the points -1, -3, and 3, -7. So exact distance, that is telling us that we're not going to be using decimals. So you're going to, if you have a square root, you're going to leave it in square root form and then try to simplify. I like to start by labeling my ordered pairs. So it's always x comma y, and the first point I just label as 1. So we have x1 and y1. That 1 is a subscript. It's not an exponent. It's below. And if you're typing, you would use an underscore to indicate that. You would use an underscore, and that shows that the number goes below as opposed to an exponent. So you want to be very careful about that. And then the second point, I'm just going to call x2 and y2. Underscores, those the subscripts, those numbers that are underneath the letter, we just start using those as labels. So if you see something under a letter, it's a label. If it's above the letter, then it's an exponent. So I'm going to start by writing the equation. We have D equals square root x2 minus x1 squared plus y2 minus y1 squared. I'm making sure my square root goes all the way across. If it doesn't, that is not technically mathematically correct. So I'm going to now plug in my numbers. And basically what we're going to be doing is the order of operations on the right side. So I'm just going to put the layout here, and then I'm going to use a different color to put in my numbers. So x1 and x2 here. So let's see. First we have x2, so I have that labeled as 3, and then minus x1, which is -1. So I'm going to put that in parentheses. So we end up with 3 minus -1. And then we have y2 minus y1. So y2 is -7 minus y1, which is -3. So your first step is to plug in your numbers into that formula. And then we're going to follow the order of operations. So anything where you're subtracting negatives, that's the same as adding. So we have 3 plus 1 squared plus -7 plus 3 squared. For both of those, we're subtracting a negative, so that turns into addition. So again, now I gotta get my square root. I need to simplify. So 3 plus 1 is 4. So that's 4 squared. -7 plus 3 is -4. So then that's going to be plus -4 squared. The order of operations, we've simplified inside the parentheses. Now we want to do the exponent. So now we need to square these numbers. So 4 squared is 16. And -4 squared is also 16. So when you square a negative, you get a positive. So now we want to add inside the square root. 16 plus 16 is 32. So exact distance, we don't want to take the square root of that. It's going to give us a decimal. So we need to simplify the square root of 32. So we're going to simplify that radical. And I'm going to do that by making a factor tree here. So that's 16 times 2. And then 16 is 4 times 4. And 4 is 2 times 2. So I'm making my factor tree so that I know how I'm going to write this as a product of primes. And 32 is 2 to the 5th power. So now I'm going to be kind of messy and write this to the right because I don't have a lot of room here, but this is, I can actually keep the equal sign because those are equivalent. Equal to 2 to the 5th. Normally I would keep going down. Now when you're taking the square root and you're simplifying, you want everything to have an even exponent. So we're going to rewrite this. So we're going to take it so that it's 2 to the 4th times 2. So that one of the exponents is even, and we can take that square root. And the square root divides the exponent by 2 when you take the square root, and it leaves the square root. So 2 to the 4th becomes 2 squared when it leaves the square root symbol. And then we have that square root of 2 left over. And then 2 squared is 4. So our final answer is 4 times the square root of 2. And that is the exact distance. So if it says exact, you need to make sure you have no decimals, but you want to also simplify it as much as possible. Are there any questions?
No, ma'am.
All right. If you do need more help on simplifying radicals, I do have a video on that. And I'm sure that YouTube has tons about simplifying radicals. In real life, we usually just use a decimal version because we don't really need exact answers. But if you're doing pure math like this, where it's not tied to an application, then we keep it in exact form. And for sure, you're going to want to know how to do this in exact form for when you answer and put your stuff in ALEKS. So the next formula we have is called the midpoint formula. And the midpoint is just the halfway point. And so you can see in the formula we have, it's divided by 2, kind of indicating that halfway point. It is literally just the average of your x values and your y values. So you're just averaging your points out. Just a point about notation here. So capital M is midpoint. Later on, you'll see a lowercase m. So lowercase m is called slope. So there is, in math, there's a difference between capital letters and lowercase letters. Because they can get confusing, I usually just write midpoint, or sometimes you'll see it MP for midpoint. I generally don't use a capital M because it does get confusing with the symbol for slope, which is lowercase m. So the midpoint is an ordered pair. It's not a number, it's an ordered pair, so you still have to have your answer in parentheses. So those parentheses you see here are required in your answer in order for it to be indicating a midpoint, because it is a point, it's an ordered pair. So here we've got an example. Find the midpoint of the line segment whose endpoints are 3, 6 and -4, -1. So I'm going to label my points x1, y1, x2, y2. And then the midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So I'm going to plug those in, and I'm going to do those in a different color again so that you can see them sort of standing out. So x1 I have labeled as 3, x2 is -4, y1 is 6, y2 is -1. It's really easy to accidentally put the wrong numbers here, so that's why I label my points so that I can double check and make sure that I'm plugging the correct number in. So once you've plugged in the numbers, then you want to actually simplify, so we need to do the addition on the top. So 3 plus -4 is actually -1, so that's going to be -1 over 2. 6 plus -1 is 5, so that's 5 over 2. And so that is our ordered pair. We're going to leave it as a fraction unless told otherwise. And that is the midpoint. That is the halfway point between those 2 points. Now I'm going to actually open up Desmos so I can graph these for you so you can see a visual. So Desmos.com, I'm going to just click on the graphing calculator. And so you get this graph, and to graph an ordered pair, you just literally type what you see. So our first ordered pair was 3, 6. So I'm just literally typing that, and you can even add a label to it if you want. And then I can add a second one here just by, you keep adding these. The second one, parenthesis, -4, -1. Oops, I must have hit a key. -4, -1. And so you can see that those are our 2 points. So it does say that there's a line segment. So if there was a line between there, that would be the line segment if we had connected those. I don't think we can, Desmos doesn't allow you to connect those with the line. So now the midpoint would be somewhere between there, about halfway between. And so I'm going to put in the midpoint. So that's -1 over 2. And then I need to hit my arrow key to move over. Then 5 over 2. And then I'm going to just add a label here. So visually, you can see that point we got for the midpoint looks to be halfway between the other 2 points. And it is exactly halfway. If you used the distance formula to find the distance between one of the points in the midpoint and then did the other one, the distance would be equal. And it should be equal because it's the halfway point. So It's halfway between, so it basically divides that distance in two. There is another website that you can use for graphing that is better when you have like geometric stuff. So it is called GeoGebra. It's like half of geometry and algebra. And so I don't use this one as often. I find it a little confusing. But they do have a graphing calculator. It seems to be taking a bit to load. So you can see it looks very similar to Desmos. So I'm going to actually do the same thing we did. Label, put in a point. You can see that it graphed it. And it does a little different. You can see it actually gave it a name. The other one was -4, -1. So the nice thing about GeoGebra here is that you can actually draw lines between these or segments. They have some more options here. You can draw a pen. They've got things called vectors. So it has a few more options. I don't see anything where you can just do a segment, but I'm going to eyeball it using their pen. Okay, so it's not a perfect line, but it's not bad. But I'm eyeballing that line segment. And then I can go back to the calculator thing here. And so let me put in the midpoint and let's see how good my line is. -1/2 and 5/2. Okay, so my line is not perfect, but you can see, at least visually, that it does look like it's the halfway point between these two points. I was, not perfect with my line. But that can give you a way to kind of eyeball it if you want to use this website instead, because it's got some other options here where it has like sliders and stuff like Desmos is, but it has some more geometric kind of things here. There are ways to, I think if you don't do just the graphing calculator, there's other options, like you can find angles. I don't remember how to get that part open. I wonder if I just went to here instead of doing the graphing calculator. It looks almost exactly the same, but I know that there's angle options. Okay. So if you don't click graphing calculator, you have more options here. So you can see we can actually do a line segment. You can find the midpoint. And so let's do this. Okay, so let's repeat what we did, and we can use this to double check. So I'm going to put in our point, 3,6, -4, -1. So I'm going to scroll down, click segment, and then I can click the 2 points, and then it makes that line for me. And then I can click midpoint or center. I click the segment, and now it's putting that right there. It labeled it C, and you can see it's -1/2 and 5/2. So that's a way to double check. So this is just a different graphing calculator that you can use. I only really use GeoGebra for trig stuff or for like double checking midpoints and distances, because you can actually use it to find distances here. So there's this button distance or length. You click on the line, and then it only gives you the decimal version, though, not the exact version. But you can kind of use this to check your work if you want. So are there any questions on the midpoint? Okay. So next is solutions and graphing. So everything we've done up to this point, we've only had one variable. We've been basically just solving for x. And our solution is basically a number, or if you have like a quadratic, you might have two solutions. Absolute value equations have two solutions. There were some equations that might have multiple solutions, but for the most part, they had one solution. Now we're working with two variables because we have an x and a y. And now we don't have a single number that's our solution. We have an ordered pair that is the solution, and it's actually there are an infinite number of ordered pairs that work in these equations. So the solution set is all sets of ordered pairs that make the equation true, and there's an infinite number. So instead of listing all of those numbers, we usually just graph the equation, and the graph is all the solutions. So if you have like a line on a graph, every ordered pair on that line is a solution to the equation. So we use graphing to visualize solutions rather than trying to write down every single possible number here, because there are technically infinite solutions for an equation that's in x and y. So we're going to start by just double checking, is something a solution or not? And so you do that by just literally plugging the numbers into x and y and then seeing if your equation comes out true. It's the same thing when we're checking our answers for x. You would plug in the number you got, see if your equation is true. So it's the same thing here. We're just plugging into two things, x and y. So I'm going to label, and this time I'm just going to label it as x and y because we have a single point. So these are two distinct problems. I'm going to be checking two different solutions here. So I'm going to take my equation. I have the absolute value of x minus 3 minus y equal to 4. So I'm going to be plugging in my x value, which is 1, because that's the first number in the ordered pair. And then my y value, which is 2. And so now I need to use the order of operations on the left to simplify. So first I need to do inside the absolute value, which is 1 minus 3, which is negative 2. So I have the absolute value of negative 2, and I have negative 2 equals 4. Now the absolute value makes things positive. So when I take the absolute value of negative 2, that becomes a positive 2. So 2 minus 2 equals 4. And 2 minus 2 is 0. So we get 0 equals 4. So that is false. That is not true. And this tells us it is not a solution, because that ordered pair doesn't work in that equation. So we can do the same thing and check the second ordered pair that we have here. Again, the first value is x, the second value is y. So absolute value, x minus 3. So x is labeled as negative 2, so it's going to be negative 2 minus 3 minus y, which is the second point, which is negative 3. And I put parentheses there because I'm subtracting a negative, so I want to make sure that doesn't get too confusing there. And then that is equal to 4. So I need to simplify. So inside the absolute value is negative 2 minus 3 is negative 5. So I have the absolute value of negative 5. And then when you're subtracting a negative, that's positive. So that's going to be plus 3 equals 4. And then absolute value of a negative is a positive, so that's going to be 5 plus 3 equals 4. And well, 5 plus 3 is 8. So this also comes up with something false. So this is also not a solution. The thing about equations with two variables is that while there's an infinite number of solutions, there are also an infinite number of values that are not solutions. And it's really difficult to just come up with two numbers and actually make them work in the equation. If you just randomly came up with two numbers for an ordered pair and plugged it in, it's very difficult to actually find one that works. Mostly you're going to find things that don't work. So this is not something that you want to like guess and check. And so we usually rely on graphing, and we have a very specific way that we do graphing to make sure that we do actually have ordered pairs that work. Or any questions on here? Okay. So this example, identify the set of values x for which y will be a real number. So guessing and checking in ordered pair is not going to find you a solution most of the time. But what you can do is look at an equation and try to figure out, well, what x values work? And then what we end up doing is saying, okay, I know that any x in this range, this set works. So as long as I plug in one of those, then I'm going to get a y value that works. And so that leads us to how we end up graphing. We need to first decide what values can you plug in and still get something that makes sense. So we consider something that makes sense as it comes out to be a real number. So we don't want to have anything that comes out with imaginary numbers or undefined because we can't graph those. We can only graph real numbers, positive or negative, for either x or y. We can't graph undefined and we can't graph complex numbers. That is just not part of the graphing system. So these are two common types of equations that you may see. And so we want to think about, well, what numbers am I allowed to plug in so that I don't get undefined or I don't get negatives? The first one on the left here, with y equals 2 over x plus 7. We want to know what x values are we allowed to plug in here. Notice we have a fraction. So if we have a fraction and we want to make sure that we get an actual number, that means we cannot divide by 0. So we have a fraction, can't divide by 0. So since the dividing is the denominator, that tells us that our denominator, which says x plus 7, it cannot be equal to 0. So we use, this is the not equal to sign. It's basically equal to sign with a line through it. And so we just say, okay, that denominator, x plus 7, can't be 0. But other than that, we assume any other number we plug in should work. So what you do is you first decide, okay, well, that can't be 0. Then you solve. Just like we would solve with a regular equal, but now we're solving a not equal, but the rules still apply. So I can subtract 7 from both sides. This would say, well, x cannot equal negative 7. 0 minus 7 is negative 7. So what this tells us is that we can plug in any number we want for x except negative 7. If we plug negative 7 in, we're going to get undefined and we can't graph it. So this is basically called the domain. The domain of something, and you talked about this a little bit when we were learning about rational expressions, and it was talking about the domain. The domain is what values am I allowed to plug in? What values make sure I don't get into any problems? So when it says identify the set of values x for which y will be a real number, it's basically all real numbers except negative 7. So we can plug in anything for x except negative 7. That gives us a problem in the denominator. Now the equation on the right is a square root equation. So we have y equals square root of x plus 11. So what we know about square roots is that the inside can't be negative. Because if you take the square root of a negative, you end up with complex numbers and imaginary numbers, and we can't graph those. So we know our inside can't be negative. So we indicate this by taking the inside, which is x plus 11, and that needs to be greater than or equal to 0. So we can't have 0 inside there. We can take the square root of 0, but we just can't have a negative. So I'm ending up with an inequality here. And so we're going to solve this for x so that we know what values of x are we allowed to plug in. Because we have to make sure whatever we plug in, and make sure that inside is not negative. So I'm going to subtract 11 for both sides. And we get x is greater than or equal to negative 11. So this means I can plug in any number that's equal to negative 11 or larger. Again, this is called the domain. As long as I plug in a number that follows that rule, I'm going to get a y value that I can graph, basically. I'm going to get a real number out. So usually with this, because it's an inequality, we write it in interval notation. So that would be a negative 11 to infinity if we write that in interval notation. So understanding the domain and understanding what values you're plugging in helps you when you start graphing, because it tells you, well, I need to make sure I can plug in numbers that aren't going to give me problems. Because when we graph, we can put in an infinite number of answers, so you want to make sure you pick the right ones. Are there any questions on here?
I have a question.
Yeah, go ahead.
When we get the interval notation, I always get confused on how to write the answer. Like I'll write the negative 11 on the right side instead of the left side. Like how do we know 11 should be on that left side there?
We always write it from the smallest to the largest. So negative 11 is smaller than infinity, so that has to be on the left.
Okay, so that's what the rule is, just because it's small.
Yes. Yeah, it always goes smallest to largest.
Okay.
And I'm pretty sure that there is, I'm going to open up the classroom because I'm pretty sure that I have, it might be in the supplemental materials. Okay, let me just pull up.
I didn't know if it was like something with like the X and the Y, if it should be on one side versus the other.
Here, so in the supplemental materials, I have this chart of set builder and interval notation. And so this shows you what your inequality looks like and then how you write it. And so if you follow this chart, like we ended up with something that was x greater than or equal to negative 11. So that's the yellow spot. So that has to go right here.
Okay.
So having this, copying this down can help you a lot because it's always going to be the same based off of what the inequality looks like.
Okay.
I have the graphs here to show you kind of what the graphing shape will look like, although it's not perfect. I scanned it. The scan didn't come by perfect, but it always follows these rules.
Okay. Okay. All right. Thank you.
You're welcome. Are there other questions? Okay. So graphing. So how do we graph these things? We do it by basically plotting points. Just you plot a series of order pairs that work in the equation, and then you connect them with a line. And so we usually do this by making a table. And so the steps are, you pick any input or any x value you want, but you have to make sure, as a general rule, you want to be able to plug in some negative numbers. You want to plug in 0 if you can, if it's not excluded. And then you want to plug in some positive numbers. And we choose those because we want to make sure that we have a full picture on our graph where we have some negative input, some 0, and then some positive input. So you can make sure it covers the whole graph. And what you do is you just literally take those numbers that you picked And you do have to know the domain, so you want to make sure it's something you're allowed to plug in. That's why we cover the domain. But you plug those into your equation, you solve your equation for y, and then that will give you the missing point. So you pick a number for x, any number you want essentially, put it in the equation, and then figure out what y is. And then that gives you your pair that you can then plot. And the general rule is you want to have about 5 of these to get a good picture. And then you just plot your points and then you connect them, and that will give you a good graph of what it looks like. Now I know I'm running out of time here, so I'm going to skip ahead to intercepts here, and then I'll talk about graphing with Desmos. So intercepts. An intercept is where the graph intersects the x or the y axis. We could have both x and y intercepts. We may have only x, we may have only y intercepts, but it's where it crosses or hits those x and y axes that we have, like the plus sign basically. The x-intercept is written as an ordered pair, some number comma 0. Basically, it's where your y value is equal to 0. That's the x-intercept. And then the y-intercept is where the x value is equal to 0. So when you write it as an ordered pair, you have 0 comma some number. So I'm going to open up Desmos, go back to what we had here, and I'm going to just clear these out. And I'm going to put in the two, oops, wrong slide. Where'd it go? I'm going to type in these two equations. So that way you can see what really that domain means and what it looks like. And we can talk about the graphing and all that kind of thing. So I'm going to start with the left one here. And when you're putting that in Desmos, you basically just literally graph what it says. So I'm going to just shrink this down so you can see it side by side here. So I have y equals, and then to get the fraction, you can hit the / button right by shift, and that creates a fraction. So then I can put in 2, and then I can use my arrow key to go underneath it and type in x plus 7. So this gives me my graph, and I'm going to scroll, so it's just click and drag here. And you can see, and I can use the scroll wheel on my mouse to zoom out or to zoom in. So if I zoom in, -7 is right here. So if you're looking at the graph, so we said that x can't be -7. There is no part that's graphed at -7. You can see basically any other x value has a graph. And you can zoom out and you can see that pretty clearly. Any x value has a graph except for x equals -7 where you have a problem. So that's what I mean about the domain, is that if we plug it in, we can't actually graph it. We get something that doesn't work. And so you end up with this gap. And so there's a gap in this equation at -7. I'm going to now graph the second one. So if I want to turn this off, I can just hit there and then it stops the graph, but it doesn't delete it. So the second one here, I have y equals, and then you might be wondering, well, how do I do a square root? If you type in, see, that might have been too fast for you, S, Q, R, and then the T, it turns into the square root symbol. There's also, down here, you can also find the square root symbol here if you don't want to learn the keyboard shortcut. And then make sure you're inside the square root. And so we have x plus 11. So you can see that we solved x is greater than or equal to -11. So that was where the values were plugged in. You can see anything less than -11 here, we don't have anything graphed. We only have things graphed greater than or equal to -11 because those are the only numbers that work in the equation. And so you can zoom out and you see what it looks like. It just keeps kind of going on and on and on forever. So now to talk about the intercepts here, this point where it goes through the vertical, the y-axis, that's the y-intercept. So we can zoom in, and you can see that it's going to be some decimal here. If I click on my graph, it kind of puts a point there, and it tells you where it is. It's an approximate. It's not exact because it's got a decimal, but it does tell you that ordered pair. So the y-intercept has an x value of 0, so you can see the first point is 0, and that has only that y value. So that's the x-intercept because that's where it's crossing. I move over here and see that as I zoom in, I can keep getting closer and closer. It hits at -11. Even though it doesn't go through, even though it doesn't go through the x-axis, this is still an x-intercept because it still hits the x-axis here right now. We do have a y value of 0. The x-intercept is where y is equal to 0. And you basically only have an x value. So we have an x value of -11 and then a y value of 0. So this is called an x-intercept. And you could have things with more than one x-intercept. You can have more than one y-intercept. There's no rule that says you have to have a certain number of x or y-intercepts. They're just where they cross on the x and y axis. Now, let's say I wanted to graph this equation and I wanted to do it by plotting points. You basically make a table. So in Desmos, you can actually do that here with a table. And you pick the x value. So I'm going to actually turn this off. So let's say I wanted to graph -3, -2, -1, 0, 1, 2, 3. You get to pick any x values you want. And then what you do is you see where I have my y1 here. I think if I can type in an equation, and you see how I get a little thing here. It says equations are not allowed. So, okay, so let me delete that. Two variables. So you see I have x1 here. I need to also call it x1 here. So this is where the underscore button comes in that I showed you to get that subscript. So when you're graphing by hand, you're basically making a table. You pick an x value, you plug it into your equation to get the y value out, and then this gives you a series of points. A graph is when you connect those points. You connect and follow the pattern, and it goes on forever. So what I just graphed here was x plus 11. I didn't do the square root here. So if I wanted to see the whole graph, I just do y equals x plus 11. You can see that it goes through those points. So when we graph by hand, we plot points, and then you connect the line, and that gives you your whole picture. Now, I'm not expecting you guys to do a lot of graphing by hand. I want you to understand what it means, but you are welcome to use Desmos to do the graphing for you. But I do want to make sure you understand that basically all of these points are solutions. That you plug them into the equation and they work. There's an infinite number of them along this graph that we have here. And when you connect them, that's what forms the actual graph of the equation. Are there any questions? All right. So I overplanned. I ended up with way more slides than we had time to go through, but I got through all the important parts basically, which is understanding what intercepts are, understanding like the definitions and things like that. I do encourage you to read through and take a look at the examples in the textbook so you can see how they graph some of those by hand, so you have an idea of how that works. Worth looking at in the textbook is how they find the x and y intercepts algebraically, which means not looking at a graph. When you find them algebraically, you're basically plugging in 0 for one of the variables and then you solve for the other one. So it's not too hard, but that's why we learned how to solve all these different types of equations. So you can solve and find the intercepts, because finding them using algebra means you're going to have to solve a square root equation or solve an absolute value equation or solve things like that. Like we used solving an inequality to determine what values we're allowed to graph. So the first half of this of college algebra is basically learning all of these skills so that we can apply them to graphing. Everything from the graphing on is going to be taking what we did in the first half and now using it for graphing purposes and for analyzing graphs. So that's what really, when we get into real college algebra, is now we're looking at graphs. What do graphs mean? What do these things all mean? What are these properties? What do they tell us? That sort of thing. So you're going to be using a lot of stuff in the first half with graphs. Any outstanding questions that you guys have for me?
Good, thank you.
You're welcome. How about you, Jason?
No, ma'am.
All right. Thank you guys for showing up. I appreciate it. I was actually surprised when I logged in and I saw, wow, people are already on already. So that was awesome. I will make sure that I post this tomorrow morning along with my PowerPoint so you can get all those definitions and everything like that. And I hope you guys enjoy the rest of your night. So take care.
Have a good night.